Hi, my name is Martin Moore, and this is my steering showcase. The aim of this project is to show an understanding and provide information on the topic of steering before we explore the hydraulic power steering lightly. Up until the year 1817, the entire front axle of the car was used to turn the wheels. This resulted in reduced accuracy of the turning and the capability of the car. It resulted in overturning and an increased wear on the tires of the car. Rudolf Ackermann was the first to patent a stub axle steering system, which made sure that the wheels were attached to the front axle by joints. This allowed for us to turn the wheels at different radii and resulted in a tighter and more controlled turn. This Ackermann's principle saw a rise in rack and pinion steering, which took up very little space and had low production cost in front-wheel drive cars. We still see it in modern vehicles. The only difference is that after the 1950s, we took greater steps and took a greater interest in implementing and developing power steering systems. A rack and pinion gear set is enclosed in a metal tube when implemented for turning a car. Each end of the rack protrudes out of this tube and is connected to a tie rod. The pinion gear is attached to your steering shaft, and when you turn the steering wheel, the gear spins, moving the rack. The tie rod at each end is connected to the steering arm on the spindle, which turns your wheels. The rack and pinion gears convert the rotational movement of the steering wheel into a linear motion needed to turn the wheels, and provides gear reduction, which made it easier to turn the wheels. Your turning capability is affected by the load weight, the incline, and the weather. To counteract some of these, a hydraulic power system can be used, in which a torsion bar is used to control the direction of flow of hydraulic fluid to either side of a cylinder inside of the steering column. The rack and pinion. This pumps the fluid to the opposite side of turning to push the cylinder and the rack in the direction that you wish to turn. The steering geometry is known as your caster angles. Caster is the angle of the steering axle on the vertical axis in line with the car's body. A positive caster angle results in better highway stability and steering feel, whereas negative caster angle results in less traction and poor handling. Camber is the angle of the wheel on the horizontal axis, which pivots in and out of line of the car's body. A positive camber results in easier wheel turning, whereas a negative produces countersteer, making it harder for the wheels to turn. Toe is the difference in length between the front and rear of the wheels. A toe-in configuration reduces your steering response and increases your straight line stability, whereas a toe-out does the opposite, increasing your steering response and decreasing your straight line stability. A zero toe is parallel and is ideal for most cars.